Well, welcome along to another video. You may remember a couple of months ago I was working on this GEC Selectest meter when one of the resistor bobbins failed, making the meter pretty useless. Well, thanks to the kind gesture from Mr. Paul Codeeze, and here's a photo of him, I was very lucky enough to be gifted this new Selectest meter, so I've now got two. This one does actually work. Now this one's in much better condition overall. This one has a little bit of flaking on the dial scale, and also the reset button's missing, and the needle is very slightly bent here. But what I'm going to do is take this meter apart and put the dial scale from this one and the front cover here onto this one. So it's not going to take very long, but I hope you'll keep watching. Right, before we go into the deep dive, let's have a quick look at the slight differences between these two meters. This one is actually slightly earlier than this one. This one's serial number 66,000 and something, and this is 63,000. So, you know, around about 3,000 serial numbers different. Now if you look at the little red disc there on the meter needle, it's about half a centimetre up from the lip here. And if you look at this one, if you can just see it, I'm not sure if you can, it's tucked down just below the lip here. There's also some differences on the printing of the dial here. Two different fonts are used, and the way the scale is calibrated is slightly different. This one has smaller numbers and this one has a little bit larger numbers. So some slight differences, as I say, ostensibly the same meter really. So let's start taking them apart. Well, here's the two meters apart. This one is the one that Paul sent me, and this one is my original one. Obviously you can see the difference. This one's absolutely filthy. But here's this thing with a red disc that I was showing you. So it looks like this needle here is about 2 or 3 millimeters shorter than this one, which covers the very tip of the needle here, covers right over the end of the scale here, and this one doesn't. Quite strange. I'm not going to do anything with that because I'll end up breaking it. There's nothing you can do really to replace this needle or make it any different. The only thing I can think of is someone smashed it with the reset button. The reset button would sit over this trip switch here, and if they've mashed it while that needle's been sat there, which is a fault of these meters, it's actually not very well designed in that respect. If they've mashed it, then they might have professionally soldered it or something, but I can't see how they get more needle length. There's a bend here which is much shallower on this one. Yeah, this one's got much more pronounced bend from the side. Let's just bring it up and show you. You can see that bend where the needle appears out of the meter. Out of the movement, and this one's got a much shallower bend. So what I'm going to do is remove this scale, and this has been worked on, I'm sure of it. If you look at the sort of spring bits here to stop the needle smashing to the side there, they're vertically posed, and this one is horizontal. Someone's been in there, and that one doesn't even do anything. Someone's been in there and changed those. So I'm going to carefully remove the scale. In fact, let's just do it now. and then we'll get inside and we're going to clean this. Or shall I leave the scale on? I might leave the scale on actually and clean up the inside, and yeah, just in case I whack the needle downwards, because there's nothing behind this scale to stop it. And then we'll switch the scales over once I've cleaned it. These are absolutely filthy. These are actually felt, which aren't in this one. I might take those down and wash them and dry them. You see they've got a nice coat of oil and stuff all over them, and I guess they were originally white. So I'm going to do that. This meter's really filthy actually, especially in the movement here, and the movement does feel very slightly sticky compared to that one, very slightly, and I'm not sure if it's touching the scale. It's never a good idea to bend these. Now we've got clearance. Yeah, we've got clearance all the way along. So I'm going to do some cleaning and then we're going to come back. All I'm going to use is isopropyl alcohol. No oil will go in here. You don't oil the pivots or anything like that, or these switches. So I'm going to come back when that's done. Right, here's most of the cleaning done. This was absolutely filthy. Let me just reach over here. You can see some of the stuff that came out of this meter, like old grease and stuff. I don't know what that is, but blech. Anyway, so I've taken the dial plate off, and this is actually quite a heavy bit of metal, quite thick. And here's the parallax mirror that sits just behind it. And what I wanted to show, these are the nuts here that hold the resistor bobbins on the other side here, and I've got to be careful here in case so they hold these resistor bobbins, which is what's gone on this one here. But having this will enable me to find which of the bobbins has gone on this one. So there we go, and the meter needle moves nice and easily. I've cleaned all around the cutout here. This is the cutout bit here, and that seats nicely now. It wasn't, it was up. And yeah, I'll get this little bit cleaned under here where the needle goes, and we can move on. But yeah, very cruddy inside for a meter. Very dirty. Well, I've had some difficulty in resetting the cutout on the working meter, and I just want to show you what the cutout's for and how it works on the broken meter here. Now, the idea of the cutout is to protect the meter movement if you were to apply, for instance, volts up the ohms range. Now, the idea here is there's a spring inside here and a pair of contacts just here, which when the meter needle accelerates across here, it'll trip something and it'll throw the contacts open, and therefore breaking any connection between the input and the meter. So I'll try and bring it in. If you can, I'm not sure if you can see, I'll try and keep it steady. The pair of contacts is here. So you've got one pair of contacts inside the meter on a spring and another one just here, and I appreciate this is not the best light, on a little copper bronzy strip there, much like the metal they used inside the plug. Copper and bronze, Andrew. Brass. Anyway, so the idea is the meter needle swings across so fast and with so much force that it trips this side of the cutout, this little spring here. that throws open the spring inside and these contacts break apart. So when you align the end stop here, it needs to be just before the spring, so you have a little protective end stop for the meter needle there. And this one is, it's lost the little plastic bit on the end there, so you reset the end stop just before the needle trips, and you can see the spring's quite a way back from when it's at the end, so let's try and keep it at the end. So you've got another 1/4 inch really, and my arm's in the way. You've got about 1/4 inch between, it's hard to show you, 1/4 inch between there and the spring cutout just there. So it knocks that spring, the pivot inside here flips open, it throws apart the contacts, and that's how the cutout works on these meters. So the last thing I'm going to do really, and I just wanted to show this, is to calibrate the meter. Now you calibrate the meters not only by the resistances inside, but you've got a magnetic shunt here which sort of allows for the aging of various components inside. So what I've done is fed 1.5 volts in, it's on the 1.5 volt range, and I'm just adjusting the magnetic shunt to make sure the needle sits over the 1.5 volt marking here. Now everything else should fall into place then. It's not going to be quite so accurate down the bottom here. This sort of meter isn't. They are most accurate towards the last 30% or so of the scale. And in fact Avo, to make their meters more accurate, gave the calibrators 7 different, I think it was 7 different versions of the scale plate to suit the best linearity of the meter here, if that's the right word. But anyway, I've done this, it's all nicely adjusted. You don't want to play around with this shunt too much, and you definitely don't want to undo these bolts here really. That can seriously ruin the meter. So there we go, just that little shunt there, and it's roughly the same on Avo meter Mark 8 as well. Not the later ones, they've got a shunt inside a plastic box, but the earlier Avo 8 2s and 3s. But don't play about with it unless it really needs it, because you can quickly ruin it. So there we go, it's ready to get boxed up. Well, here we go, here's the meter all done. The last thing I did to it was replace the perish rubber feet on the bottom here with some feet I bought from Amazon. The only thing I haven't done is tested the resistance ranges. There's a special battery connection, I believe it's a doorbell battery, and I need to get some spade end connectors for the 2 wires in here. Not something you can buy, so I'm going to have to wait for a radio swap meet, which of course aren't happening at the moment under these COVID restrictions and lockdown we have at the moment. So it just sort of leaves me finally to thank Paul once again for this lovely and fantastic and very welcome gift of the inside of this meter. One day I do plan to get the other one up and running, which is here. So this is the outside of the case he sent me with the inside of my old meter, which does actually work on the 1.5 and 15 volt ranges still. It just doesn't work on anything above that. So that's the end of this one. Yeah, thanks Paul, and more to come. Thanks for watching.